Quantum computing is a new type of computing where we're using the world at its very smallest, so using individual atoms to encode information. If we can control the world at that level, we can control their quantum states, we get an exponentially predicted increase in computational power. It's grown rapidly over the last few years, and what we've realised is it impacts pretty much every industry. So when you basically need a lot of computational power, where you've got lots of information or you need to sort information very quickly, quantum computers can do that in parallel rather sequentially than you can in classical computing. And so the areas where we can see this coming in is things like weather forecasting, economic modelling, predictive areas in optimization problems, so looking at the stock markets and how they behave, how to optimize traffic patterns, how to get delivery of goods much faster, even right down to drug design.
In the current project that's funded by the Australian Research Fund, I make the devices that we will use for quantum computing later on. But we just make test devices with these components on them, and we send them to India where they do noise measurements.
International collaborations are essential if you want to do world-leading science. We looked around the world at who was the best at doing these very low noise measurements, and certainly at the Indian Institute of Science and Professor Ghosh there is fantastic, so we knew that we wanted to partner with him. To get those to happen, you have to have some kind of Kickstarter for that to happen. It's very difficult within your own funding streams to create new projects. What I've really enjoyed about this grant is that we go back and forth with each country. I've got to see the measurements being done in their labs. The students have come over here and seen how the samples are made. There's nothing really that replaces that face-to-face interaction that really allows you to understand the problem. They can look at the devices we've made and they can tell us what are the issues that make that device behave badly. And as a consequence of that, we know how to change our fabrication process to get them working much better. And so that really does accelerate us to get towards the goal of getting a scalable quantum computer that works in the best regime.
They're very good at what they do in India. On the other side, what we do here, making these devices, we're currently the only group in the world that can do that. So it's these two very narrow expertises that matches up in this project.
The research is definitely going to increase as a function of time. The more we work together, the more interesting things we find. Actually, the more things we don't understand. So the more we work together, the more doors we open, and we can see that collaboration getting stronger and stronger. And I think the rest of the world is really quite interested in what we get up to.